Okay, so now we've solved exponential functions and we've solved some simple logs. Now we're going to solve logarithm exponentiating. So let's think about this. What is that? That is a new vocabulary word for the day, and all it means is make an exponent. Okay, fancy word. Solving logs by exponentiating each side, by making exponents of each side. Okay, so let's look at the steps. Isolate the log. That means get this term by itself. Get rid of that -1. Okay, in the problem number 2 down here, isolate the log would mean get that term by itself. Get rid of that 12 before you exponentiate. Okay, isolate the log. Exponentiate each side to the base of the log, or convert to exponential form. Now, once you've done that, you'll use the inverse class or two ago, okay, which will cancel the base and the log, or the log on the base, and you will solve for x. Okay, so it's almost intuitive. All right, we're going to isolate. Let's add 1 to both sides. X plus 3 equals, we add 1 equals 2. Now, exponentiate. Make an exponent with base of the log is 4. So all that I do is I say, okay, I'm going to take this whole side and I'm going to make it an exponent. Well, if I do that with that side, then I need to do that with the other side. There is exponentiating. Okay? Exponentiate. Exponentiate. Okay, so then what happened? Well, we know that the log base 4 and the 4 will cancel each other out, and what I say is that this will fall to the floor, and we'll get x plus 3 equals, now this is an entity. I've made an exponent, so what is 4 squared? 16. And now I solve for x, subtract 3, x equals 13. Okay, now I must check by substitution to make sure that my solution is valid. Okay, so I go check the log base 4, plug in 13 plus 3 minus 1 equals 1. Let's see if it does. So the log base 4 of 16 minus 1 equals 1. So the log base 4 of 16, let's evaluate this. 4 to what power is 16? 2 minus 1 equals 1. 1 equals 1. Check. So x equals 13 is a valid solution. All right, so what I would need you to do is stop the tape. Try these two solutions by isolating, exponentiating, canceling with inverse properties, solve for x, check. Okay. Once you're done with that, we'll go on and do the last method of solving for the extraneous solutions. Extraneous means they are true algebraically, but not valid. Okay, you get them with algebra, but then when you plug them back in, they would cause an error on your calculator. All right, so now look that these problems are different. We have log base 2 plus log base 2. We can't set things equal because we have a sum here. We can't rewrite yet. So what do? Well, when you have the log base 2 plus the log base 2, you can condense. Okay? So you look at this situation and you condense. And so I only condense this side. So I say the log base 2 of, now it's going to be the subject of this times the subject of this because it's addition, so it moves to multiplication. So I have the log base 2 of x times x minus 7 equals 3. So I'm just doing the math. The log base 2, if you want to make hard brackets, now you're going to distribute. X squared minus 7x equals 3. Okay, So now I'm at a situation where I can exponentiate both sides, right? And that's how I'm going to get rid of this log base 2. So I'm going to make an exponent. This is base 2, so I raise this side to 2 and I raise this side to 2. Then I go ahead and do the next math. These will cancel, and I will get x squared minus 7x equals 2 to the third power, which is 8. And now I see that I have a quadratic. I just move this over. I have a quadratic that I can factor, hopefully. All right, so subtract the 8. I get x squared minus 7x minus 8 equals 0. Do my factor tree. What multiplies to negative 8 but adds to negative 7? 1 and 8 make the 8 negative. They'll multiply to a negative and add to a negative. So, and this is a is equal to 1, so it's a simple factoring. X plus 1, x minus 8. Then I get x equals negative 1, x equals 8. Okay, I'm done. Well, as far as solving. But now I have to check for extraneous solutions. And extraneous solutions are going to occur when the subject of the log is negative. You can never take the log of a negative number. So let's see. If I put negative 1 in here, it'll be the log of negative 1. So what that tells me is x equals negative 1 is extraneous. Okay, that is extraneous because it would not be valid. Now we should check x equals 8. So I should do a check and say the log base 2 of 8 plus the log, you check back in the original, base 2 of 8 minus 7 equals 3. Well, 8 minus 7 equals 1. Okay, so now I'm doing the math. The log base 2 of 8. 2 to what power equals 8? 3. Plus, this is the log base 2 of 1. 2 to what power equals 1? 0 equals 3. 3 equals 3. Check. All right, let's do it again. Now we're going to condense. Oh, well, that is the exact, that is a typo. So we're done. You guys stop the tape and try this problem. Solve, check your solutions, see if it's extraneous, and then do your final check. Okay, so you must check your answers. There may be extraneous answers. All right. Now, what I would like you to do is there's a classwork that is going to be turned in and graded for effort, and I will check 1 or 2 problems for accuracy. So I want you to complete that in class, that classwork today, okay? And the classwork that I'm talking about looks like this, okay? It's day 37 classwork, solving logs and exponents, okay? So it's got exponents on one side, logs on another side. Okay, you may work in groups, and please turn that in at the end of class. All right, I'll see you on Wednesday.